My name is Oleksii Petrov, and I'm a solutions architect at Jain Irrigation. You may know me as a program committee member here at Fwdays or as a speaker on some conferences. And today I have a special guest here, a person who knows the hard parts in the architecture, and frankly, almost everything about the architecture, in my humble opinion, with a total experience of 35 years, author of numerous books that are well recognized in community and becoming a new standards in the community, founder of developer-to-architect.com, and the host of Software Architecture Monday that I absolutely love to watch every Monday bi-weekly, Mark Richards. Mark, hi. We are so thrilled to have you here, and thank you so much for joining us today.
Yes, well, thank you.
Does it sound about right, like your intro? Would you like to add anything?
Yeah, no, just that very excited. My friend Neil Ford and I recently published two different books. Last year, in February of 2020, we published the fundamentals of software architecture, but we just published 2 weeks ago our latest book, which is Software Architecture, the Hard Parts. And so that is at least out in ebook. The print version should be coming out in probably a week or two, but we're very excited about that. It really covers all aspects of distributed architecture, including some of the hard stuff and hard decisions that we need to make, especially, like I say, within distributed architectures themselves. So just very excited about that part.
Yeah, I'm so waiting for the paper copy of that book. So I saw a preview on O'Reilly, but yeah, so excited.
Yeah,
and yeah, congratulations with the book launch.
Thanks.
Prior to this talk, we gathered some questions from our community, and I'm going to ask those questions today. So does it sound like a deal?
Yeah. Yep. Perfect. I love that. Let's do it.
Perfect. So I just to warm up, I think I bet you've been asked this question a gazillion times now, but like especially for Ukrainian audience, please, what are the fundamental skills and key attributes to become an architect?
Oh, yes. Well, so that's an interesting question. I've been an architect. I've been in the industry for, as you mentioned in the intro, about 36 years now. 26 of those kind of a software architect. And so it's kind of interesting. I've seen that role really change quite a bit in the past, well, almost 30 years. However, some of the key skills, I really see this divided kind of into half. I always maintain that 50%, half of being an effective software architect is the soft skills, the people skills part. One of the things of the foundational aspects of a skill that's required as a software architect is really kind of gaining that technical breadth of knowledge. As a developer, we have a lot of technical depth. In other words, we're experts in quite a few different maybe languages or platforms. Maybe we're focused on the user interface, or maybe back-end development or database. However, as an architect, it's necessary to kind of expand that technical breadth. The things that you know a lot about, or the things you know, kind of that you don't know. In other words, things you're aware of, but not necessarily an expert in. And that's what I mean about that technical breadth. Awareness of various platforms, technologies, tools, frameworks, and know just enough about them so that you can know if they're a viable solution or not, or know that they're options. So that really is kind of that first foundational piece of being an architect, is expanding that technical breadth. But more to the point, though, it's more about what I like to call architectural thinking. It's kind of seeing things with an architect's eye. I like to do this great analogy. I usually put up on the screen a picture of clouds, just some clouds, white clouds in a blue sky. And it's interesting to see the different perspectives that different types of people have on those clouds. A meteorologist is going to look at those clouds and start thinking about the scientific aspects of them and the cloud types and stuff. Whereas, for example, an artist would take a look at those clouds and kind of render clouds in a very, very interesting way with different colors and different shapes. So that's what I mean about seeing things with an architecture point of view. Let me explain what that means in kind of answering this foundational kind of skills. Architectural thinking is really about first analyzing trade-offs, identifying trade-offs, and then analyzing those to arrive at the appropriate solution. And so that's really kind of one of the first aspects of really about architectural thinking. But it's also understanding the business problem, the context of the business problem, but actually why we're doing this particular engagement or project or system. That's also kind of one of the key aspects, especially within architecture, because that's where we usually extract all of those architecture characteristics. That's what I call them. Some people call them ilities or non-functional characteristics or non-functional requirements, system quality attributes. There's a lot of different names for them, but things like scalability, availability, what's really important in the system, and kind of extracting and identifying those characteristics. That's another part of this architectural thinking. So those are some of the kind of key, more technical skills, but also then those foundational aspects are also the soft skills and people skills of being able to lead and guide a team through the implementation, for example, of the architecture, and key negotiation skills, mentoring, coaching, these sort of things. So those would be, I kind of like to divide it really into two pieces, those aspects of being an architect.
Yeah, absolutely. Absolutely. But that said, like we got another question in that regard. Like, if you're just starting your career, or like, is there any time required for you to become an architect? If you want to become an architect, I mean, can you become an architect in a year after starting your job? Like,
no. Well, I can tell you, of course, the answer, obviously, with any question we could probably actually talk about in this Q&A is it depends. I can tell you that I first started my official kind of role and title as a software architect was 10 years after I actually started being a developer. Part of that time frame really is trying to gain that kind of technical breadth of knowledge. But it's also developing kind of those people skills as well. So the time required really is, it's kind of interesting. I don't know if there's any real time when you could just wake up one morning and say, I'm a software architect. In my view, this role really does evolve through the course of your career. I get this question actually quite a bit from development teams and stuff. It's like, so, how long would this take, or how can I get started? And I usually answer, start right now. Start by kind of focusing on that architectural thinking and expanding your technical breadth of knowledge. The general progression really is from, kind of typically the developer to tech or senior developer, then maybe a technical lead, and then a junior architect, senior architect, and then there's different titles of architect.
Yeah.
But I don't really think there's an inflection point where all of a sudden you just become an architect. However, by actually starting to focus on some of the expectations of an architect, and actually as a senior developer, start to work on those, people will notice. And you will find that you are more responsible for harder questions, harder decisions that you make. More architectural decisions will start coming your way. And then you'll start to lead some teams and start to really understand the domain and the business domain. So the time required is going to vary based on different contexts, I would say, that you're in. However, one of the things I always encourage, and that is to really focus on those core expectations. And let me kind of briefly tell you kind of what those are. So, like, for example, an architect, what do they even do? That's really one of the first preparation pieces.
Nice.
Like, I do want to be an architect, but I'm not sure what these people actually do. But one of the first key things is to actually make architecture decisions. And, there's this tangent we can maybe talk about later. What's the difference between architecture and design? But it's starting to make those kind of harder questions. It's continually analyzing an architecture based on those architecture characteristics and recommend any sort of solutions for improvement on those. Measuring, are we scaling? Are we available? Those are the really responsibilities of an architect. It's kind of expanding that technical breadth of knowledge, keeping up with trends in all areas really of IT, and really kind of having that exposure to different platforms and technologies. One of the ways I do tell people who want to really become architects is start, it's called like stretching your comfort zone. In other words, we get comfortable in a particular language, technology, platform. Look for opportunities within your company to stretch your comfort zone into another platform or language that you're not familiar with. This is a great way of kind of expanding that level of technical breadth. So those are really some of the key. Now, a couple of key skills is that of, again, those people skills, but negotiation and understanding the political climate of the enterprise, for example. And so those are really some of the key skills. The time it takes to get those, start now. Start now on focusing on these aspects that I'm talking about. And again, a lot of it depends. The people skills, sometimes you can read a book, but those are required. And I usually will encourage people to start working on leadership, mentoring, coaching. One of the great things to shorten that time frame, start to be recognized as a leader on your team. Take on some additional problems that may occur. Do brown bag lunches. And we call them here in the States brown bag lunches. But, at lunch, just do a quick 30-minute technical session on something. Anything that a conference such as FW here, that you find that something that resonates with you, bring that back to your team and just do a quick presentation on it. These are really simple ways of suddenly just starting to become recognized as the leader, the decision maker.
Yep, great answer. Thank you. But you said that some morning, just rephrasing, some morning you need to wake up and become an architect, right? So some morning you need to go and get that title or that job, or I don't know. So I think there might be some also a confidence problem, right? When you got the skills, when you got an expertise, as you mentioned, soft skills. So I don't know, any advice? It's when do I need to, if I got anything, if I'm cool tech lead, I'm sharing my experience, when I need to change the title, when I need to should try, changing that title.
Interesting. Yeah, no, and it's a good question, because the thing is, there is a difference in the role between a software developer and a software architect. And one of those transitions is, unfortunately, coding less and kind of designing more. And this is one of those transition points. Now, I still am, I consider myself a hands-on software architect. I mean, I still do write code. However, that's gone from 100% when I was a developer to now around 20% of my time. And that's something of this transition where you start moving further away from the lower level details of the implementation of something and more towards that role of understanding the business problem and forming solutions. So, kind of an answer to your question, it really is that transition when you start to realize you're engaging more with business stakeholders, for example, understanding the problem. You're engaged more with understanding decisions and trade-offs and how to form a design. This kind of transition is usually where you can say, you know, I'm doing more design work and figuring out the solution to problems than I am actually implementing them. And that's really the time when you can say, yes, I think I can call myself an architect. It's interesting, though. I do want to say one last thing on this, that sometimes understanding what an architect does is necessary to know whether you want to become a software architect. I have a passion for technology. I love technology. And it's frustrating sometimes as an architect to not be able to roll up my sleeves sometimes on projects and dive into the code. I try to carve out pieces to kind of maintain my technical depth. But this is something that people who want to become a software architect need to be prepared to do and shift in that transition from less coding into more design work.
Yeah, absolutely. Absolutely. Agree with you. So, next question, kind of like soft skills, I'd say, and our decisions we make about trade-offs. I know you like trade-offs in your analysis.
Yes.
Let's say we have a scenario, we have a business that wants features like now or better yesterday, and we are an architect, and we need to decide what's best to do, like faster development, better architecture, like, and how to balance between those.
Yeah, this is something that I found is increasingly common, and that is we don't have time for a really good architecture. We have to code this very quickly. And so how do you balance that difference right there? The key part here and kind of the key word of this really is all about evolutionary architecture. In other words, in the old days, what we used to do is architects would parachute in, we'd understand the problem, form a solution, create lots of pretty diagrams that look very complex and maybe some corresponding documents, and hand those off to development teams. And then the hapless architect would go off to another project and do the same thing. That model simply won't and doesn't work today. Because you're right. We have increased demands to get things done faster. We have to start development work right away. We can't wait 2 or 3 months for you to create the perfect architecture. And that's what evolutionary architecture is really all about. So what I mean by letting the architecture evolve is that the process of architecture and creating an architecture and making all those architecture decisions is usually done in conjunction with software development. You see, architects, even though some may say they do, architects don't have all the answers. As a matter of fact, it's implementation of the architecture, which not only reveals more details and refinements to the architecture, but also starts challenging and validating our assertions and assumptions we're making about the environment, about the problem. And so really what I'm saying is that you don't have to make a choice of either one, but rather let the architecture evolve as we learn more about the implementation of that system. Now, it's interesting because this, in my opinion at least, is exactly how to make architecture work. But it does require a couple of things. It requires a strong collaboration between architects and developers so that they're really working on the same team. These aren't two different camps. But number two, it also requires that, well, it's part with that same piece about that collaboration piece of, oh, yes, that the architect obviously has to be involved in the life cycle of that whole entire application or system, even after it's in production. And so one of the things I see very frequently happen with this role of an architect is that, well, I just do architecture. So I'm going to fix this problem or create this new system or do this migration and then move off to something else. Well, let me ask you, is the architecture that you created 3 years ago or 5 years ago or even 10, there's some systems that maybe even 20 years ago, is that still viable today? Is it still correct? Is it still satisfying the needs of the business? Because that's what architecture does. Let's say, for example, 20 years ago or 10 years ago, our company, our business was really concerned about growth. We wanted to get as many customers as possible. So that's all about user satisfaction and also scalability, the ability to scale our applications. So we design an architecture that supports those things. Fast forward 10 years, well, we're not so concerned about that anymore because people aren't coming to us because our application isn't fast enough. So now performance and responsiveness are the two key things the business is worried about. The architecture wasn't built for that 10 years ago. And so what I'm really saying here is the architect needs to be continuously involved with any given system. So that's what I mean about kind of that collaboration, not only in creating an architecture, but the ongoing maintenance of a particular system. And sometimes does impact all of those architecture characteristics we need to support.
Do you say we can't hire a contractor for a week to do us like all the architecture?
I doubt it.
Okay. Yeah, coming off of the evolutionary architecture, I love that. But there is a question like where to start. Do we have a default architecture we can start like, or if we, let's say, low on budget, right? We have short time to delivery, time to market. Can we say that, I don't know, modular monolithic architecture is the style we want to start, or is there any base point where we start?
Yeah, you know, that's kind of, it's interesting. I want to think about that question a bit because each architecture style that we have, especially if you divide monolithic, which are single deployment unit applications, or distributed architectures, there is a dividing line, whether it's a startup company or a big, large corporation, about which architecture style is most suited for this particular application or this particular architecture style. In our book, The Fundamentals of Software Architecture, Neil Ford and I created star ratings for each architecture style based on different characteristics. 1 star means doesn't really support it that much. 5 stars means that's an architecture to use. So we have 2 problems here. Startups are usually constrained by a couple of things, cost and time. I mean, we can't wait 6 months to get a system out. We just don't. We don't have that time. I mean, this is a great business idea. We're ready to go, but we don't have systems in place to be able to do what we need to do. And also, we don't have a lot of money. We're not sure if this startup's going to work. So why should we invest all this money in something that this idea may not work? So startups have a pretty unique situation in that regard because of those two constraints of time and budget. Because of that, the simplicity aspect of monolithic applications are 5 stars in terms of its simplicity. It's good. These are very straightforward, simple architectures versus entering into what I like to call the land of Oz, distributed architectures. These are where our superheroes live. Super powerful. I mean, these are all the Marvel and DC Comics superheroes. But it's also a lot of villains. So us mere mortals live in the monolithic world. However, the question you asked, though, about specifically the modular monolith is a place I actually like to start. But I will say, it depends. But let me say what it depends on what. For a startup like this, or if we're not sure of an idea, the general advice given by experts is start out with a monolith because it is cheaper and faster to develop in most cases. And learning about that system, then break it apart if needed into a distributed architecture. It's good advice because we may not have all the answers about how the system's going to be used. Modular monoliths, popularized by Simon Brown, an architect from Jersey, are really popular today, more so than the traditional n-tiered layered architectures. And the reason is because of there's actually 2 reasons why it's potentially a good choice. And I'll say potentially because I want to show you the trade-offs. Modular monoliths allow for domain-driven design, where the focus, it's actually a domain partitioned architecture, where our functionality, if we do undergo DDD or domain-driven design, where we're really focusing on the domains rather than the layers within that architecture. A good example is how we structure our code. Think of all of our namespaces that we use. And I'm just going to use a namespace in Java. It would be a package structure, or maybe it's a directory structure in some other languages, but we'll call it a namespace. What is the structure of that namespace? You see, because in a layered architecture, we might have app.business.customer.wishlist. And so you see the format of the nodes of that namespace are dictating the kind of architecture that we have. What I just described to you is a technically partitioned architecture, which would be like a layered architecture where you have presentation, business, maybe persistence or service, shared services. But did you notice the namespace app.business.customer? The second node describes that whole layer of the architecture, technically partitioned. But a modular monolith switches these around. And so the namespace would look like this, app.customer.wishlist. And that's the subdomain within customer. So these modular monoliths are well suited for that domain partitioning that we do if we think about our problem in domains rather than layers. And also the other reason I really like modular monoliths is because it's a lot easier to break up a modular monolith into a distributed architecture than it is a layered architecture. So a future migration, it's going to be a lot easier to do. But modular monoliths are not a silver bullet either, because modular monoliths require kind of a domain focus within our application. And maybe that doesn't exist. Maybe our teams are organized in Conway's law by silos. We have teams of UI developers, teams of backend developers, teams of DBAs. And so the layered architecture, the traditional layered monolith, fits really well with that kind of approach. And that's what's called Conway's law. So when we move to a modular monolith, we really it's more well suited for those cross-functional teams that we typically have sometimes within agile environments. So what I'm saying is it kind of does depend, and it depends on the nature of your problem. Is it really domain focused, or is it really kind of partitioned in layers? And also your environment. And the third thing it depends on is, what do you change typically in your application? Let me give you a really good example. Let's say that most of our changes occur in the user interface, in that whole presentation layer. No, the business logic and the database, those are fine, but we continually change our UI. If that's the kind of scenario you have, then a traditional n-tiered layered architecture is thumbs up for that, because you're changing a technical layer. That kind of change in a modular monolith would be spread throughout the entire application because it impacts every domain. However, if most of your changes are focused on a particular small domain area, and let's say we change all the customer functionality, or we're changing order or payment, modular monolith works really well on that, because all of that code is isolated into only one part of the application, not spread all the way through. And so, but the bottom line to your question really is, generally, especially for startups, it is good advice to usually just start with a monolith, and with the thought that we may break it apart into a distributed architecture when we have more time and understand which pieces need that superpower of a distributed architecture. One last word of advice, though, because this is a great question. One last word of advice. If you do start out with a monolith, even though you think you might be going to a distributed architecture, but we got to get this thing out fast. The advice I usually give is keep your object hierarchies fairly flat. So one of the things in most monoliths that we get excited about in object-oriented programming is inherit from everything, extend everything. And once you start doing that, it's going to be more difficult to start breaking apart that monolith into a distributed architecture. So don't go crazy with a lot of object hierarchies. Try to use more now I'm kind of lost for the word, inheritance composition. And in that case, I usually favor composition over inheritance, with the justification that we're going to probably be breaking the application apart.
That's interesting, because you mentioned the modular monolith and a front-end development or UI development. And what I usually see that like backend teams can be like, I don't know, modular, and they're trying to do some domain-driven design and break up into services or components. But the front-end team is typically like the whole piece, Only like recent years, micro front-ends and all that thing is becoming more popular. So maybe you will have those verticals from the UI to the like backend and then to the storage, right? I mean, like different teams have like different architecture styles based on a layer, and it's not like one or another. I don't know.
Yeah, and that's well said, because you can have different architectural styles if we are talking about separate efforts for a user interface versus some backend functionality. But it's kind of interesting you mentioned this, because this again requires a lot of collaboration, which is why I really favor cross-functional teams with specialization, because now we have that collaboration built into each team, and we can discuss which kind of architectural style and structure works best for this particular part of the system, including the connections between the user interface and the functionality. You are correct, though. Absolutely, micro front ends. As a matter of fact, I think it was 2 years ago, I guess, I was at a conference, and I said, the buzzword of the year is going to be micro front ends. And I said, this will continue for several years. Of course, then COVID hit, disrupted. That was a disruptor in so many ways. But I think it's still very much on the hype curve and close to the top. Part of the reason that I think this is definitely a trend and a necessary one is because when we start talking about microservices, we get so excited about the backend functionality, and we can achieve super high levels of agility, testability, deployability, scalability, availability, fault tolerance. All of these are the benefits of microservices. And we go crazy on our core functionality. But then we have a large monolithic user interface accessing all those services. And guess what? We no longer have our fault tolerance, our scalability, our agility, because I can make a change on a backend service and I can deploy that within the hour in production. But we can't do that with a monolithic UI. And so all of a sudden it's like, oh, wait, yeah, you're right. Most of our changes are going to require UI changes and contract changes, and that's deployed every week. There goes our fast deployments. So yes, this idea of breaking apart our user interfaces is a necessary thing to do in distributed architectures to be able to achieve all of these great powers. One of the things that I would say to caution people on is the same thing that happened with microservices about 7 years ago. Micro, what's micro? Micro means small. And so let's create these really small services everywhere when we don't necessarily have to. And that was the mistake that most teams made 7 years ago, 6 years ago, even now, as a matter of fact. I believe, and it is my crystal ball looking at the future, that we're going to experience the same exact thing with user interfaces. What is a micro front end? How it's a lot harder, at least in my experience and opinion, to break apart a user interface than back-end functionality. And we've got consistency to worry about. We've got frameworks that don't work well with small partitions of a user interface. So I think our biggest challenge moving forward is going to be not only understanding what a micro front end is, but getting that right level of granularity within the user interface.
Yeah, exactly. And when I'm thinking about that, like when we got those micro front ends, we will still have like flat and monolithic UI, and you'll have shareable components, and you will have to solve the same problems you have on the backend with the microservices. How to share functionality, right? How do I pass this button into my multiple like front-end apps and use it everywhere because it's same design? Should I repeat? Should I copy? Should I, yeah. All those problems become popular in the front ends soon.
Exactly. Yes. Which, when we think about microservices as being single-purpose functions deployed as separate units, whether they be serverless or not, it just, you're right. All the things you just mentioned don't work well in a user interface because we're sharing all these components, and we want consistency across each of those components. Or each of those front ends, I should say. So yeah, it's a lot more of a challenge.
Yeah. But I want to get us back like a bit to architecture, like I mean on the backend part, application as a whole, but still. You mentioned two things. First, code connection to domain, like as a domain-driven design when we like design code according to our domains, and architecture like based on a company style and size and structure as a Conway law and all that stuff. But the question is like, can we connect architecture styles to verticals? Like, can I say that there is a perfect architecture for IoT or I don't know, for e-commerce? Is there any typical connections that if you go IoT, you need to take this, and if you go e-commerce, you should take that?
I love this question because back when I was an employee of IBM, this was one of the things that I focused on was, is there an alignment between vertical markets and architecture? And again, the choice of architecture is really based on the core needs and characteristics. Does our application have to scale, or does it need to be fast or highly secure? Do we have to change it frequently and get those changes out as fast as possible? These are the kind of characteristics. However, I did at least observe. Oh, so the answer to your question is not really. It does depend on the characteristics. However, I have noticed some associations and alignment with various architecture styles and various industries. Two in particular that I'm involved in. As a matter of fact, I would say probably three, but two primary industries. Finance and trading is one of the primary industries I'm involved in, stock trading and stuff. Most of these systems require an extremely high level of performance and responsiveness. And for that, I usually see an alignment with more event-driven architectures, leveraging async within those high-speed, high-demand kind of applications that you do see in trading. So there is somewhat of an alignment that I would say with kind of the financial trading and event-driven architecture. It's a good match. Another match that I did observe and still do is with insurance. Most insurance companies, large or small, the old service-oriented architecture was a great fit, at least especially in the past. It aligned very nicely with that kind of vertical because of the need, or two reasons. First was the need for sharing enterprise services across different divisions. Good example, in my insurance company, I have car insurance, I have homeowners insurance, I've got business insurance, I've got travel insurance, I've got commercial insurance, I've got all these different kinds of insurance. And each one of those departments have their own systems with their own customer database management. And so if I move, I have to call 5 different phone numbers to initiate that move of a change of address. The sharing of enterprise services and concepts like customer well, that was one of the main drivers, for example, of service-oriented architecture. But I have seen, now, again, these are just generalizations, but especially with insurance, you walk in and say, what kind of platform and technology and languages do you folks use here? And the answer is always the same. All of them. So this heterogeneous interoperability of any given request to say, I would like an auto quote. How much is my insurance going to be for my car? May hit some Java code. It may certainly hit some COBOL code in some sort of mainframe, probably hits a little bit of .NET code somewhere hidden there, and finally gives me back the answer from a RESTful call. And so, that's where the power of that kind of architecture style sits. And that's a nice alignment. So these are some that I've seen a lot of: defined benefits, defined contribution systems, health systems. Again, event-driven works well in these verticals because we really don't make requests to systems. When I get married or somebody gets divorced or you have another child, you get into an accident. I mean, these are all events that happen, and that's what triggers processing. If I file a claim that's based on an event, I got into an accident. And so, that's where event-driven also, even describing the problem, I'm talking about event-driven architecture. But I will finish this question by saying, although there are some alignments vertically like that, in general, what we mostly see are hybrids. One architecture style does not suit every single need of every single part of even a single application. And so forming hybrids, for example, of an event-driven microservices architecture or a space-based microservices architecture, or the most common one I see, which is the cross between service-based and microservices. That's a very, very common hybrid. And so these are kind of hybrids that form irrespective of those vertical alignments. But yeah, there is no one single universal standard architecture that fits most cases. It's just not, unfortunately, a thing. Used to be the monolith, but not anymore.
Yeah, but you gave great examples of use cases for event-driven. I love them a lot, like about insurance and all the stuff. Yeah, actually, they are like a ledger, and you go with your events and in cases and all that stuff. Yeah. Mm-hmm. Do you have any use case for serverless then? I mean, it also kind of trendy and low code, serverless. Let's do not buy servers. Let's do not buy programmers. I don't know. Yeah. Do you have any use cases?
Oh, yes. I've got opinions about everything. It is my strong opinion, I would say medium held, that serverless is a deployment strategy, not its own architecture. And the reason I maintain this, actually, I would have to say that's a strong opinion, strongly held. And the reason why I maintain this is if we describe microservices, I mean, what is microservices? Well, it's single purpose functions deployed as separate units of software, each owning its own data. And that forms a bounded context. Well, let's describe serverless. What is serverless? Well, it's single purpose functions deployed as separate units of code. Oh, so I've just described the exact same animal. And so I see serverless as a means of deployment for microservices. In most cases, we can have serverless and containerized in the same application context. So where I see, and you are correct, absolutely, it did kind of reach a hype curve at one point. But I think we got all excited about this deployment strategy and writing, Google Cloud Functions or Azure Functions or Lambdas. And it's like, this is cool. Look, I just write some code and just, deploy.
Unlimited scale, unlimited performance.
Yeah. And however, I think what I at least observed was a lack of trade-off analysis in terms of the benefits that I just described and the disadvantages. For the most part, the cold start problem is pretty much plagued most serverless applications. Serverless functions triggered, it does its work, and then it ends. And so these are really well suited, serverless, for those kind of scenarios and situations where we do have just operations that are sometimes needing to be invoked. And it's really cheap because the cost when nothing is running is zero. And that's one of the main benefits of serverless. However, what I've observed are too many times where serverless functions are used in a continuous kind of request mode, where we've got lots of users continually making requests, or maybe even inter-service, continually making requests. And so we're unnecessarily triggering, killing, triggering, killing, triggering, killing. And this is really, really inefficient as opposed to a containerized service, which is always running. I don't have the cold start issue. It's a lot faster from that regard. And in some cases, easier to maintain and control from a scalability standpoint. And so I think those are the kind of scenarios where I question the use of serverless. And I usually turn the question back onto the team and say, based on the fact that we have to deal with all the latency from the startup, what benefits outweigh that? And a lot of times it's like, I can't think of any.
It's so cool.
Unless, of course, it was used for RDD, resume-driven development, where the team said, I need serverless on my resume, so I'm going to write these as serverless functions. Again, architecturally, it boils down to the trade-off, the trade-off analysis.
Yeah, totally agree with that. I have a question, but I don't know, tentative to ask it because I know several books out there about that. But yeah, maybe some key aspects of it because I can't like miss it because it's so popular, but it's also a broad question. Is there a way for a painless transition from monolithic application to microservices?
Oh, indeed. Oh, I love this question because this is one of my passions. As a matter of fact, this is what I've been doing for the past over 7 years now of my career, is helping companies migrate from monolithic applications to microservices. Oh boy, I've even coined anti-patterns associated with that kind of migration. But the short answer to your question is yes. And as a matter of fact, I will describe these various patterns. They are actually described in excruciating detail, as a matter of fact, in Neil and I's latest book, Software Architecture, The Hard Parts. And these are component-based decomposition patterns. So this is a very common question. I mean, yeah, we need to break apart our monolith into microservices. And traditionally and still currently, it's a really costly and painful and disruptive type of thing to do. So about 6 years ago, so I was well into migrations, and I was finding problems everywhere. It was hard to do. And I'm like, this shouldn't be this hard moving to microservices, but it is. And so I started to observe things that didn't work, but I also started to observe things that did work. And I started to form these into patterns. So let me describe kind of the flow of these various decomposition patterns to fairly, well, let's say, ease the pain of migration. Yep. The first core piece to think about where all these patterns originate is this. And this is called a paradigm shift because it's a different way of thinking. You see, when we move to microservices, the original problem was we start looking at all of our source code, all of our classes, and we start saying, this class, and this class, these would make a good service. And so we kind of pull those out from our monolith. And then we say, well, these classes over here combined with these ones would make a good service. And we start pulling those out. And you can kind of see what I'm doing. I'm kind of cherry picking various classes out of the monolith to start building services. I actually have coined an anti-pattern of that, and it's called the elephant migration anti-pattern. Because of the old joke, how do you eat an elephant? Well, one bite at a time. So let's just start chewing away at our application one bite at a time. And all of a sudden, you pull one class out and the whole thing just crashes down. The point is this: as you start pulling classes out, you need other classes that are related to it, but those classes have already been in another service, and it never, ever, ever ends. I said, there's got to be a better way. Think about this. When we write code, we write class files. Where do you put those? Well, you put them in a specific directory or a namespace or a package structure. Well, why do we do that? Why do we create namespaces for our code? And the answer is pretty clear. Well, Mark, all 10 of those class files kind of do one thing. They're all related. They do something. Exactly. So here's the paradigm shift. When we move to microservices, we don't actually move individual classes, but rather we move architectural components. These groupings of classes within a namespace that are already doing one thing really well, which is actually defining a microservice. And so with this kind of revelation that I had about a little over 6 years ago, I realized I've been doing it wrong all this time. And so what I started to focus on was refining the architectural components. Now I'll define a component because it's so overloaded. Everybody has their own definition. Let me tell you mine. A component, architectural component within a system, is represented by a namespace and a representative of all that code in that root, or I should say the root, the leaf namespace that identifies a particular component. App.customer.wishlist, something really easy, a wish list. That's a component, wish list. It contains code that manages a wish list. So the idea here is that we refine components to create a clean architecture so that we can start removing components, those namespaces, out, which actually then form services. And that's what the idea of these component-based decomposition patterns are all about. It's slow, iterative, controlled migrations or refactorings of our code so that we can effectively extract these components and build services out of them. And so the nice answer to this one is yes, there are. And these decomposition patterns, which again, this is actually the largest chapter in our book. When I first wrote it, it was 68 pages long. And our editor said, you can't have a chapter that long in the book. But I couldn't break it up. So I shortened it to 65 pages, but it's still the largest chapter in the book. But it's a series of refactorings where we identify and size our components just to make sure we have some level. We get rid of those large namespaces that contain half of the code and start breaking those up functionally. Then we start flattening. It's a pattern I termed called flattening. But when we have namespace upon namespace upon namespace upon namespace upon namespace, it starts to form these hills, these mountains in our code. And what I've learned is that it's really, really hard to break apart applications that have lots of mountains and hills in them. A good example, let's take our app.customer.wishlist. There's our namespace. So we've got a whole bunch of code in the wishlist node, which is the leaf node of our namespace or directory. That's where most of our class files are. Great, pull that out and make it a service. But we've also got code in customer. That customer node has a bunch of code. Well, what component is that? The answer, none. I call those orphaned classes because they're associated with a domain or a subdomain, not a leaf node in our namespace representing a component. And that's what the flattening does. It moves code away from what I call root namespaces and pushes it all out to the leaf nodes or collapses leaf nodes back into customer, and that would be our service. Then there's dependency management between those components, which is another pattern. And then we group components into domains. And then we extract those domains out into service-based architecture. And then from there, where needed, we break those up into microservices. And that really is the secret sauce for at least my success in migrating applications. There is a trade-off. Of course, there always is. As a matter of fact, that's our first law of software architecture we coined in our book, that everything in software architecture is a trade-off. So this sounds great. Mark, this is wonderful. Is there any drawback? Is there any trade-off to this? Oh, absolutely. There always is. And the trade-off of this safe, effective, iterative, controlled process is it takes a long time. That's the trade-off, is the amount of time it takes to refactor our application to effectively just have it magically become a distributed architecture. The other approach is tactical forking, which is very fast. This is a whole separate approach. Tactical forking really involves taking our application and watch this. We make an exact copy of it, maybe even make 2 copies of it. And then each team, like a sculptor, starts chipping away at the and when I say copy, I mean, we actually take our repository, our repo, and we actually duplicate it. That's what I mean. So each team works on their own repo and they start chipping away like a sculptor at the stuff they don't need, arriving at the service that they're desiring. This is a very fast approach. If you have just a very short time frame to get things migrated, tactical forking is an appropriate approach for that kind of model. Or if you've got just a big ball of distributed mud, we don't have any components, Mark. It's just all one big flat directory. Then component-based decomposition won't work. And tactical forking does, where we all act as sculptors, kind of chipping away at the applications. So two different approaches, but the controlled approach is what I found works most effectively when migrating. So.
Yeah, and actually that's very interesting that you mentioned that like coming to microservices through refactoring of the legacy application, because what I usually see, that company comes into like outsourcing vendor and say that we have an old system, it's bad system, bad design, legacy, it makes money, we want a new one. The same but new one, like which is better, stronger in the cloud with Kubernetes and all the stuff. Just start the development. And it just never ends. So that transition when you switch from legacy to the new one, it never happens because that like old platform also leaves and there is some support and typically there are some features and new team just doesn't keep up with doing all of that. Or if there is a change, it's dramatic. It's not like seamless to customers and to everybody. Everybody knows that change is happening because everything is breaking apart. Yeah.
You are so right. Actually, exactly to your point, Oleksii, what I usually do and also advise is in most partitioned applications where we do have user interface and backend functionality, I'll usually recommend migrating the backend functionality and corresponding data to help minimize those disruptions to the user experience. And then start tackling the breaking apart of the user interface. But I do that for another reason as well, though. I have tried it the other way, where we start breaking apart a UI and then corresponding backend pieces. And both of those efforts, which I've done both 2 times, haven't worked out well. And the reason is that it is much, much harder to break apart a UI than it is backend functionality. And it's much harder to identify those seams, those partitions of the granularity of each of those user interfaces than it is the backend. So by starting with all the backend functionality first, you identify those domains and subdomains in those bounded contexts, which allow you to drive that information up to help find those seams in the user interface that correspond to that particular domain or subdomain of functionality. And that I've had a lot of success in. So yeah, I usually kind of do back end first, then front end for those reasons. Yeah.
But you didn't have a micro frontends, right? So now you can break apart like a front-end app into microservices and do the same thing top down.
I just have to say, it's an interesting bit of trivia. When James Lewis and Martin Fowler first kind of evangelized microservices in their famous blog post, they always had the intention and notion that the bounded context would include the user interface and corresponding backend functionality and data. They never envisioned that it was only backend functionality that we're moving to microservices. Yet, unfortunately, most of us interpreted it that way, which is why now we have the effort of micro front ends, coming back to that. So it is kind of interesting. Their initial vision was that the user interface and all backend functionality and data would form its own bounded context. Something that's very doable in service-based architecture, but we're not quite there yet with microservices.
Yeah, exactly. Yeah. One question I absolutely love. Is Kafka required in microservices? Can we do microservices with? Absolutely. Okay.
No, I'm kidding. No, I'm kidding.
No, we will make a short clip of it and post it somewhere.
There you go. Yes. Confluent would be very, very happy with me. No, of course, it's not required. It's useful in microservices for several use cases. However, again, it depends. It's a great tool for streaming, very high throughput. However, if we're looking at doing an event-driven architecture, we could use Kafka for that. However, it doesn't provide a lot of the capabilities that standard messaging, for example, like RabbitMQ or ActiveMQ or even MSMQ or any of these kind of standard brokers provides. There's a lot of differences between the two. Is it required? No, not at all. Do I usually use it in microservices? Quite often, as a matter of fact. I won't say all the time, but quite often. One of those use cases, which I love to use Kafka on, is using the core API of Kafka, which is fairly fast and straightforward. But I use it for streaming various metrics, errors, all sorts of information, telemetry data. It is such a great use case, especially in microservices, because now if I'm streaming all this kind of information and analytics out from every service, I can have those go to different kinds of topics. I can write subscribers on those so that I can respond immediately. I've got runtime level information about the operations and errors of my entire system. And I love that use case for Kafka. A really good example, we use logging all the time for errors. Sure, we use logging facilities within any kind of platform or language we have. I love using those, but also streaming errors as well. And because now what I can do is write those to it, stream those to a topic. I can write a Kafka subscriber that filters to say, show me immediately anything that has fatal in it and notify me right away. I find out before anybody else does. Here's another great metric. How many errors does your service or domain or subdomain of your application produce daily? Well, I don't know. I don't know what that would be. I do, because I have another subscriber on the errors topic, which actually, based on the context of a particular service, a domain or subdomain or area of that application, I'm constantly accumulating metrics of how many errors we have. So these are great use cases within a microservices ecosystem that's my go-to choice for these kind of things. But if we're just doing like standard events or passing different kinds of transactional data around, now we get into a trade-off analysis of what are we really trying to accomplish. If I need sheer raw throughput, if I've got 45,000 requests a second that I need to process, yeah, that's the right tool for it. That's what it does really well. We're only going to get 3,000 a second on persistent messaging. We're not even going to come close to those volumes. So these are the kind of use cases. It's all based on use cases of what we're actually trying to do. And is it the right tool? You know.
Absolutely. Absolutely. One more topic I'd like to dive in is API design. So at some moment, REST became very popular. Then we saw that wars like, what is the right REST? Let us be RESTful or REST-like and all that stuff. Later, we got GraphQL saying that REST doesn't fit the front-end needs. We need a query language. We need to ask data we need streaming. We need like all that stuff. So what's your opinion? Is there a best API? What should be like? What are our key factors to choose the API and all that stuff? Yeah.
Interesting. Well, of course, you clearly know my answer to that. It depends.
Sure. But I want to hear all options. Yeah.
Oh, yeah, but it depends on what, you see. So you're allowed to say it depends all the time. So I'm saying this message to all architects out there. You can say it depends. You have to. But an effective architect will say what it depends on. In other words, yeah, it depends, but it depends on what. Let's discuss those trade-offs. And so, that's why there's always that joke, but it depends on what is always the follow-on question. It's interesting because Joshua Block, who I know, has these bumper sticker design pieces for APIs,
Yeah.
and there's 38 of them, as a matter of fact, that he has. It gets its name from just these phrases, these short phrases that he puts out for proper API design and stuff. And I really like those. I think this is a really good list of these little maxims. For example, self-documenting. This is one of the big things, whether we're talking about a programmatic API or even like a RESTful APIs or external APIs. An API that's self-documenting is +1 in my book. Also, the fact that one of the other things that Josh Block says is, names matter. And I can't emphasize enough how important that bumper sticker is from an API design perspective. Let's face it. I mean, naming things is hard. As a matter of fact, the two hardest things in computer science is naming things and cache invalidation. Oh yeah, and off by 1 errors. It's an old joke. Anyways, this is my favorite computer science joke. But names,
yeah, I love it.
I mean, everybody's heard it so many times. It's like, but I still like saying it. But names do matter because that avoids a lot. As a matter of fact, that one bumper sticker that Joshua Block specifies in his API design, it expands to explain and include so many of the other things. For example, the principle of least astonishment. I love that. One of Joshua Block's API design bumper stickers. Obey the principle of least astonishment. And what this means is don't make the user surprised about what's happening in that API call. And that's obeying that principle. The proper name should really reflect what it's doing and be self-documenting. So it's interesting, although there's 38 of them, it's interesting to note that a lot of them are interrelated and intertwined, but those are groupings of my absolute favorite ones in that list. However, when you talk about things like GraphQL, for example, these are, or all the other kinds of things we could talk about, but these are, this is GraphQL. It's kind of had its hype curve as well. Isn't it interesting? All of these things did have their hype curve. I mean, this allowed for one of the various implementations of CDC, consumer-driven contracts, providing that decoupling from stamp coupling to where I, as the caller, can have my own contract. I mean, it's my own spec. I shouldn't say contract, it's a contract, but my own specification. And it allows great API aggregation, orchestration. It's like, well, so am I missing something? GraphQL is like, thumbs up. But remember our first law of software architecture. Everything in software architecture is a trade-off. And as a matter of fact, the first corollary to our first law says this: if you think you found something that doesn't have any trade-offs, all it means is you haven't found the trade-off yet, because there's one there. So let's talk about GraphQL. I mean, so it helps bandwidth issues that are real in microservices ecosystems. It helps stamp coupling, which is real in microservices. It helps decouple services, decouple contracts. And it's like, well, so this is great, isn't it? No, maybe. Because the downside of GraphQL is that it's highly intrusive. It replaces our RESTful calls as GraphQL calls and requires a GraphQL server. And so now we may have RESTful calls going to some parts of the system, going through our API gateway, but now we have to have a second kind of gateway implemented as a GraphQL server, for example, that are making different kinds of calls into our system. And so it's highly intrusive. It's not like we could just simply replace a RESTful call that easily. So it's one of these types of things that has all these benefits, but it's sometimes either all or nothing. Either we are going to use all GraphQL or we will use REST. In a lot of cases, I see folks using both to solve a particular problem. But that's the drawback of GraphQL is just that disruption and the fact it's a different animal we're introducing into our API.
Yep, yep, I totally agree with that. Next question I have is about the team organization and the work organization, I'd say. Because in a pandemic time, many teams become distributed teams and they never work like that. And the question is how to align on everything. What kind of alignment we need, like what we need to agree upon. I mean, technical standards, I don't know, maybe some core components, maybe how to enforce this in a team when it's not sitting like in one space, when you can come to somebody and say you're doing that thing, or I don't know. But there are different approaches. I've heard about things like architecture decision records when you document your decision as an architect, or a team submit through a proposal, a request about changing architecture. Like, what's your thoughts on that? Like, what kind of alignment we can have in a distributed team, how it should look like, and what's important and what's not?
Yeah. This is such a great question for an architecture Q&A. And I'm sure a lot of you right now are saying, wait, this isn't about architecture. This is about team organization and how we structure our teams. Oh, make no mistake, it is also influencing architecture. And so a friend of mine, Alan Hullab, he's an architect. He's big in the agile space, and that's where his primary focus is and expertise. He did a keynote several years ago at a conference, an architecture conference, called the three-headed dog of architecture. And if you remember from Harry Potter, there was that, I think it was in the first book, I think it was, The Sorcerer's Stone, there was that three-headed monster dog that was guarding the trap door. And it was such a great keynote. He actually made it a five-headed dog, but he started with three-headed dog. And the idea is, what influences architecture? It's your deployment environment. It influences your choices of architecture. It's the technology that you're using. It's also the way your teams are structured, the methodology that you're using. All of these things influence architecture. And so let's talk about that head of the dog, which is the team structure and stuff. Because different architectures do align with different kinds of team structures. For example, if you've got siloed type of teams, in other words, the traditional Conway's law we talked about before, you've got UI developers on one team. Way over there are all the backend developers. We've got DBAs over here. Well, if you're doing microservices, I can pretty much guarantee that you won't get that application off the ground. It's not an alignment that works. So when we start talking about distributed teams and stuff, it does align with architecture, which is why I think this is a very relevant piece. But I love the spirit of this question in terms of all the collaboration and communication problems that occur within highly distributed teams. And we've got teams working on different domains. What do we align with? I mean, should we align with some sort of technical principle or some sort of communication standard and stuff like that? What I've found works most effective with highly distributed teams, team communication is, and in my opinion, will always be a challenge and a problem with distributed architectures. One of the effective ways I've found to kind of help address this problem is to align teams with specific domains. Again, we come back to domain-driven design, and that not only dictates kind of the structures and domains of our architecture and corresponding our application, but also the structure of those teams. So aligning teams within a particular domain area, what I used to call service owners, which are now usually architects who are responsible for a particular domain within the system. Let's say within a whole order entry system, we have all the customer stuff. That may be a customer domain. There might be an order domain, a payment domain, a shipping domain. And these have lots of services and lots of teams. a service owner, now usually in some companies called domain architects, are responsible for all the functionality within that domain. And if you can picture, if you will, dozens of teams down here, align those with a particular domain, have a domain owner, being usually an architect, assigned to manage those teams and do the architecture for that domain. They're responsible for those services. So now if you picture this in your mind, you've got dozens of teams and maybe 4 domain architects. That is where I found effective communication between teams. You see, let's say teams 1 through 12. We've got a dozen teams spread out everywhere. Team 1 wants to make a change to a contract that affects teams 11 and 12. So that change is communicated up to the domain owner, that service owner. And that domain owner now communicates with another domain owner for teams 11 and 12 and says, we need to make this change. And then that gets effectively communicated to those teams. And so you've got kind of, instead of this, now within a domain, teams do collaborate between each other and especially within the team. But if you can picture what I'm talking about here, 12 circles on the bottom and then 4 squares above that, it kind of spreads from the bottom up to those 4 squares, and the 4 squares are now doing east-west communication. And that is one effective way I have found, not only for communicating contract changes, coding changes, shared code changes, but also, as you mentioned before, architecture decision records. How do we communicate those effectively? And it's across all of those domain owners. Then in those specific meetings to other development teams. And so that's, it's kind of this go up, across, and down kind of communication model that I found really, really effective.
Yeah, that absolutely works. I mean, if you're talking to somebody who knows and covers just other systems you need to work with, it totally makes sense. The problem, though, I found with this, like, it's not a common, but it happens often that like managers gather everybody to one room, like to one virtual room, and give them a talk, and there are like many people that don't need to be there, and a talk is like just boring. Everybody's sitting listening about the new change, and 2 is talking or 3 is talking, and that's all. So so is there like you said a domain expert. It's interesting because you never get a title as a domain expert. How do you like assign those roles? Who should be assigning them? Is it like a natural thing that you become just the person who knows the most in that part of a system, or is it should be structured by somebody when we define that we have those teams and you will be, as a lead of that team, domain expert on that team, something like that? Mm-hmm. What do you think?
Exactly. And as a matter of fact, a lot of, especially larger companies that are embracing, or even smaller ones, that are embracing domain-driven design have come up with this new title of an architect called a domain architect. And instead of a solution architect or, application architect, whatever, especially in microservices, it's one way to govern and manage having hundreds or thousands of services in our ecosystem. It starts to become unmanageable and things just get dropped and lost and no one's communicating. So yeah, I have seen this transition of this role of not necessarily having to be an expert in that domain, but responsible for that domain.
I get you.
By being responsible, I become more knowledgeable about that domain than other areas of the system or other areas within that department. So yes, and by that, a lot of times you do become the expert because you're most knowledgeable about the services, the API calls, the operations, the interfaces, all of that within that specific domain. Yeah,
perfect. In the beginning, when we were talking about core skills and fundamental skills for a software architect, you mentioned the technological breadth of things you know or you look at. So in closing, I'd like to ask you, like, what would you recommend to read, to see, to follow on Twitter? I don't know, any useful stuff on the internet everybody should be watching now and to become an architect?
Yeah, so I'll share with you what resources I typically go to. One of the ways of increasing technical breadth is learning about things you don't know, the things you've never heard of, different buzzwords, Grapql. What in the world is that? Is it a language? Is it a platform? Is it a tool? I don't know. So three resources that I really, really enjoy, that I leverage myself to gain and maintain that technical breadth. The first is InfoQ, INFOQ, letter Q.com. I really, really appreciate InfoQ. One of the reasons is I subscribe, of course, and I get an email about every 3 days or so. And in that email, it's got a bold list at the top of the email that shows all of the things they talk about in that particular collection of articles. It's all free. All this is free. I love looking at that list because it takes me 15 seconds to read through there. And if I see something that I'm not familiar with, and it's like, that's a weird buzzword, I've not heard that before, I go and spend a couple of minutes looking at it, maybe 5 minutes finding out what it is. That's how I increase my technical breadth. Another resource I use all the time, which actually just came out yesterday, is the Thoughtworks Technology Radar. Again, this is free. If you go to thoughtworks.com/radar, it just got released. This gets released 2 times a year, and the fall edition just got released yesterday. This is such a great radar because this shows different platforms, tools, technologies, techniques that are either trending, things you should adopt, things you should maybe hold back on. And this is based on their collective experience and knowledge. And these are experts in the field. And the folks who write these, the radar, are the experts. And this is a great way of looking at 20 things that the radar says these are trending. Well, take a look at it, because I'll bet you know about 3 of those things. There's 17 things that they're saying, yes, adopt and trending. It's like, I've never heard of those before. That's another great source for gaining that technical breadth and awareness of techniques and platforms that you may not be familiar with. And the last resource that I usually use is dzone ref cards. Now, dzone itself is kind of hit or miss. I've seen some good articles. I've seen some really bad, technically incorrect articles. However, I love the ref cards. And these ref cards are anywhere from 2 to 8 pages long, and they talk just enough level about a particular technology or tool or platform for you to gain that breadth of knowledge and say, okay, I'm done. I don't need to investigate this any further. So these are the 3 resources I typically use. But there is a 4th, and it's this thing right here, my ear. I love talking and listening and having conversations with people. Because if you, for example, Oleksii said some buzzword, and I'm like, actually, I'm not familiar with that. I'm going to go look that up later on. It's another way of just gathering things that you don't know anything about. And it's like, I've not heard of that before. So those are the resources I typically use. Yeah.
Yeah. Thank you for the great answer. I think we just caused Mark Richards effect, and now everybody bombarding Thoughtworks website right now. They're getting spiked. So yeah, thank you so much for this talk,
Yeah.
for answering the questions. All the answers were great, and I think our audience really appreciate that.